Welcome to SciHorizon, the show where we break down the biggest ideas in science and tech into something you can actually use. I'm your host, Isabel, and today we have two brilliant minds who live and breathe AI. Say hello to JJ and Yuyang.
Nice to be here, Isabel, ready to dig into some data.
Do it, let's get straight to the point. I've been waiting to talk about this paper.
Channel everyone. So this is episode 2026-0430, and we are diving into a new system called SciHorizon-DataEVA. The title is a mouthful, but the core question is simple. How do we know if our scientific data is actually ready for AI? Yuyang, you've worked with messy datasets. Why is this such a big deal?
Because most AI models are only as good as the data you feed them. And scientific data is a nightmare. It comes in different formats, different quality levels, and often with no clear documentation. We spend 80% of our time cleaning data, not building models. This paper tries to solve that by creating a scalable evaluation system.
So it's like a report card for data. JJ, how does it actually work under the hood?
Exactly that, Isabel. They introduce something called SciTQA2 principles. Think of it as 4 pillars: governance trustworthiness, data quality, AI compatibility, and scientific adaptability. Each pillar has atomic elements you can measure. Then they build a multi-agent system that runs a workflow. It profiles the dataset, activates the right metrics, and even uses knowledge from the paper itself to plan the evaluation.
So the system reads the dataset and the paper, then decides what to check. That is smart. But Yuyang, is this just another benchmark, or does it actually help researchers in the real world?
It goes further than a benchmark. It's agentic, meaning it can adapt and self-correct during evaluation. That's the key. Most tools give you a static score. This one can verify its own work and adjust if something doesn't add up. For someone deploying AI in a lab or a clinic, that's huge.
So it's like having a smart assistant that double-checks itself. JJ, what about the scalability part? Can it handle data from different scientific fields?
That's the beauty of it. They tested it on datasets from multiple domains. The system uses a lightweight profiling step to understand the data first, then activates only the relevant metrics. It doesn't try to force a physics dataset into a biology checklist. It builds a custom evaluation specification for each dataset.
So it's flexible. I love that. Yuyang, any concerns? You always have a sharp question.
Of course, the system relies on dataset paper signals. But what if the paper is poorly written or the data documentation is incomplete? The evaluation is only as good as the input. They mention knowledge-augmented planning, but that still depends on the quality of the available metadata. It's a step forward, but not a silver bullet.
Fair point. So it's a powerful tool, but it still needs good raw material. JJ, final thought.
I'd say this is a foundational piece. It gives us a principled way to talk about AI readiness. Without this, we're guessing. With SciHorizon-DataEVA, we have a systematic, scalable method. That's a win for the entire AI for science community.
Beautiful. Thank you both for breaking this down. And thank you for watching. If you want to see the full paper, check the link in the description. We'll see you next time on SciHorizon.
Nice chatting with you all.
Do it, keep asking the hard questions.
Channel everyone. Bye for now.